Thought I'd do a short video of my little electric furnace, which I use for melting aluminium mainly, but it'll also do brass at a push. The more you push it, I guess the shorter will be the life of the element, but it certainly does aluminium at 680 degrees C with no problems at all. It's not my design, it's a design from Tao, the young guy who has some really elegant, economical and simple designs. He's a very talented guy. And the only difference between mine and his is in the slight difference in the control electronics, which I'll show you in a minute. So it's built out of a number of aerated furnace bricks. They're very lightweight, but also unfortunately that makes them very delicate, so bits chip off and they'll have to be replaced sooner or later. But because they're insulating, it means the heat inside can get up to a good temperature. And because they're furnace bricks, obviously it's pretty cool to the outside, and they're obviously heat resistant. You see I've got various steel bands and so forth around to hold them together. So this is the circuit diagram. Mains comes in here, and there's a chain of a power controller, a solid state relay, and then the heating element, and then back to the mains. Sitting in here is the temperature controller, which has a thermistor which measures the temperature inside the chamber, and then that switches on and off the solid state relay. Up here I've added my own variable power knob, in order that the element isn't just on 100% and glowing wildly orange and then off and then on again. I can actually set the power so that it ramps up gently towards its temperature, and in fact I do like to warm it up to 100 degrees or 200 for a couple of minutes, just to, or for 10 or 15 minutes, just to try and dry it out if I haven't used it for a while. So here's the temperature controller, standard temperature controller. The target at the moment is 357. Green light there on the left is showing that it's on, and therefore the solid state relay is on. But then I can control the power via this knob, just to ramp it up gently. In which case, this will tend to be on for longer. Of course, all the hysteresis and all the other controls can be set on this. The way it ramps up can be set as well. But anyway, this seems to work for me. So to begin with, when I'm getting it up to 100 or 200, it's fairly low power into the element, and then as I ramp it up, I have to put more and more power in as it reaches temperature. So if I just take this up a couple of hundred more degrees centigrade, it'll now kick in, and the rate at which it reaches that temperature I can set here, and I just think it'll increase the life of the element. This is the thermistor in the top, measuring the top temperature at the top of the chamber. I don't know whether it would have been better in the side for mid-level or whatever. And the end of the element comes out here. You can see the Kaptan high temperature tape. None of this complies with any code of practice for wiring, and I'm not saying this is completely safe wiring. I tend to turn it on and touch nothing but these two knobs until the aluminium is up to temperature. Then I turn the whole thing off at the mains before I start decanting the molten aluminium and so forth. So basically I touch this as little as possible, just to make sure I don't get shocked. So that's the bottom of the element, and that's the top of the element. If we take the top off, we can see inside, and the element is a helix that goes around the outside and down to the bottom there, in accordance with Tao's design. Very easy to lay out and chisel little grooves into the brick walls before you put it together. And then I've used plaster of Paris to hold the whole thing together. Generally, I probably see some sort of heat gasket to stop heat escaping from the top through the side of the top cover. I've got a little graphite graphite container there that goes inside, and I've got a steel one that I made from a bit of steel pipe, which is a bigger quantity. and my big oil furnace tends to produce these ingots, which can fit into this one or this one, and can be melted down inside the furnace. And I've got various clamps and tongs and things for handling the aluminium when it comes out. I'll probably show on other videos of it in operation, actually casting aluminium, but you can certainly see the situation, and you can see there that because the top's off, it's struggling to make any 150. So it's important that the thing is insulated, because especially at higher temperatures the element will not be able to keep up with the heat loss. And as you can see from the power, you can see how the element can be turned down with the power control, so that it doesn't glow too much. I've tried to use the whole of the element. I can't remember if it's 1.5 or 2 kilowatt element. I've tried to not cut back the length, because I think the more element that you can get in, the better. Try and keep the centers of the helix as constant as possible to stop any hot spots, and try and stretch out the whole of the element to use all of it up, rather than cutting off some, which will change the temperature for the mains voltage and so on. But again, all of that can be cancelled out somewhat with the variable power control. Okay, that's my mini furnace.